Alrighty, so welcome back everyone. So today is going to be logic lesson number 2, part 2. So if you don't remember what we went over last week, the coding bats section, logic 2. So we went over the first 3 problems: make bricks, lone sum, and lucky sum. And so now we're going to be covering the last couple of problems. We might not be able to get to make chocolate, but we should get through these first 3 problems. So again, these the problems in Logic 2 are basically entirely logic based, so we're going to be using a lot of if statements. So as you can see, we went over most like the easier categories. Warm-up 2 got a little harder, but it wasn't too bad. But now we're getting into like the 3 harder topics, which is logic 2, string 2, and list 2. And really, it's nothing much different compared to what we've learned previously. It's just that instead of shorter programs that only test whether or not we know what's going on or not, these programs are here to test us if we know how to actually apply it to different situations in which we might actually need to use them. So I guess without any more delay, we can just go ahead and get started on Logic 2. So the first problem we're going to be going over is no teen sum. So go ahead and read this little paragraph here and go and look at the 3 test cases, and then we can go over how we are going to be programming this. Alrighty, so hopefully you've had a good chance to read over this. So this problem is actually slightly different in that we're going to need to write a helper method, but we'll get to that. So essentially, given 3 integer values a, b, and c, return their sum. However, if any of the values is a teen in the range 13 to 19 inclusive, then that value counts as 0 except 15 and 16. So those don't count as teens. So this is kind of the rule that we have to follow, so there's nothing much to it. It's just returning their sum except in that case. So what we're going to do is we're going to write a separate helper function defined fixed teen that takes an integer value and returns the value fixed for the teen rule. And we'll get to why we should do this later in this program. So we're going to go ahead and just define no teen sum, and we're going to be given the parameters a, b, and c. A, b, c. So that's how we kind of go off and define the beginning part of it. So when we think about it, in order for us to effectively do this, we need to make sure that we take care of that one test case. Now, if you think about it, we're just going to be repeating the same test case for all 3 of these numbers. So this is where code reuse comes into play. And we learned before functions are to make our code much more neat because we don't have to repeat the same code, and instead we can just call the function. And this is like the prime case in which this is going to be very, very useful for you, as you don't need to repeat this same piece of code 3 times over. So essentially it asks us to go ahead and define a second method, and the second method is going to be called define fix_teen, and we get one parameter. This parameter is n, and this parameter means that this one's the number that we're going to perform the teen rule on. So if we look carefully at the teen rule, we can see that we obviously are going to have to separate out the numbers from 13 to 15 or 13 to 14 and 17 to 19. So we're just going to write a very basic if statement. So if n is less than or equal or greater than or equal to 13, and n is less than 15, or n is greater than 16, n is greater than 16, and n is less than or equal to 19. And if it is in any of these cases, then it will return 0. And if it is not in any of these cases, then it shall just return n. So there's nothing else much to it. So we haven't gone over anything too complicated yet, but I want to make sure you guys completely understand what is going on here when we define our helper method. So I'll give you guys a second to think about that. Alright, so hopefully you understand what's kind of going on. So now that we kind of see, alright, we know how to get our method into a small function so you can repeat the code over and over again. Now we just need to remember, how do we call this method? Well, since this is a function and there's no class that we need to call before it, there's no object that we need to create, all we need to do is just type in fix_teen and whatever number we want to put in there, and it will return whatever happens within this if statement here. So essentially all we need to do is we can just go ahead and type return fix_teen A plus fix_teen B plus fix_teen C. And if you think about it, this is much simpler than going ahead and writing an if statement for every single one of them, and perhaps even redefining variables. And when you make parameters when you take parameters from the function, it's often not a smart idea to directly kind of change their values around and kind of change essentially changing their values, because you always want to make sure that you keep track of the parameters correctly. And of course you can define your own variables. You can put d is equal to a and you can change d, but it's often not a smart idea to go ahead and change a, b, and c, which is why this works so well, because instead of changing a, b, and c, it just goes ahead and runs the rule over it, and then it returns it for us, so we don't have to write any extra code. So essentially this one method here gets shrunk down into one line, and this one line kind of performs this entire if statement. So I'll let you kind of think through this. Make sure you really understand what's happening, because you're actually going to be doing this a lot if you do a lot of programming. hopefully you guys really understand this. Again, it doesn't seem too complicated, but when you go ahead and do it yourselves, oftentimes it can be quite confusing. So I'm just going to go over the basics of it. So you're going to want to define a separate method, and within this method you're going to do whatever you want to this number right here. Now this number, when you go ahead, you return 0, you return end. It doesn't change this number. So remember, if we put in fixteen-a, it doesn't change the value of a. Rather, this statement returns a certain number pertaining to a. So a still remains the same, but it will return the value of fixteen. Now, on top of that, we need to make sure that we understand that how we can call this function. So this function can be called as long as you have this one parameter, and it will return this rule of fixteen. So there's actually one more thing that we can do, and this is simplifying this if statement further down. Now, this isn't something that I will always recommend you to do, as occasionally this can be a little bit confusing. But in this case, since these return statements aren't long, and the only kind of long part of this if statement is right here, it's perfectly fine for us to do this. So what we're going to do is we're going to type return 0 if this condition. If we don't return that condition, then we return n. So we can essentially, we can go ahead and delete all that code over there, and we can see the code runs perfectly fine. Right, so we can go ahead and we need to think about it. Alright, well, how does this exactly work? Well, I'll let you guys kind of look over this for a quick second, and then it's basically purely logic. And this is why Python is so easy to learn, because this quite literally follows what you would think if you were to regularly read this. Alright, so hopefully you kind of understand how this goes. It's literally just reading it out loud. Return 0 if this, else return this. So the common mistake you can make is you put return here as well. You don't in fact need to do this because you already have this first return here, and it's essentially just returning this condition. So there's nothing really else you can do to kind of simplify this program further. Again, go back to this. If you ever need a reference in how to write a helper method, again, this is a helper method or a helper function, not a main function. This would be your main function right here, because this is a function that's actually being called. Now, again, one more thing. This is a tiny bit more abstract, but there's something known as recursion in programming. And recursion is essentially just going to be repeating a certain task over and over again, except instead of doing this through the use of for loops, you're going to be doing this through the use of if statements and calling the same method over and over again using different modified numbers. And we might be able to go over this later on in this course, or perhaps in the next course, but this concept will then get into slightly more complicated concepts, so we're not going to go into too much detail with that. So that kind of wraps up this question, no teen sum. So hopefully you guys completely understand this, so we can now move on to the next question. So the next question is round sum, and Pranav will be doing this question. So let me bring that up. is. Alright, Pranav, you can go ahead.
Okay, we'll be doing round sum. First, I'll give you some time to read the question. Okay, so what this says is for this problem, we'll round an int value up to the next multiple of 10. If its rightmost digit is 5 or more, so 15 rounds up to 20. Alternately, round down to the previous multiple of 10 if its rightmost digit is less than 5. So 12 rounds down to 10. Given three ints, a, b, and c, return the sum of their rounded values. To avoid code repetition, write a separate helper, def round 10 number, and call it 3 times. Write the helper entirely below and at the same indent level as round sum. So basically what this means is if the ones digit is 5 or more, round to the next multiple of 10. And if the ones digit is less than 5, round down to the previous multiple of 10. And then after we round all three numbers, we add them all up, and that's the answer of the problem. See, let's see this example, how this example works here, first one, so you guys can understand better. So we round up 16 to 20 because the ones digit is more than 5. We do the same thing with 17 and 18. So after you round all three numbers here, you get 20, 20, and 20. And then at the end, we add all three up, and we get 60. So basically, that's what we want to do here. So now let me explain this answer I have here. So remember that the problem wants us to use a helper called round 10 num. So why do we even use helpers in the first place? So we use them because we want to get rid of redundancy. We don't want to write if statements 500 times. So that's why we use helper. Whenever there is rounding, one key operator to use is modulus or the remainder operator. So if you don't remember, the symbol for this is the percent sign. So basically what I did here was if the remainder of the number divided by 10 is less than 5. So that's this first line here. So this line figures out what the ones digit is. For example, if we do 43 divided by 10, the remainder is 3. So 3 is the ones digit in 43. So 3 is less than 5 in this if statement here. So we move on to the return statement. We do the number minus the number modulus 10. So number modulus 10 is essentially the ones digit. So now let's run a test of this. Let's use 43. We do 43 minus 43 modulus 10. 43 modulus 10 is 3. So 43 minus 3 is 40. And that's what we want. We want it to round down. So now let's move to the other condition, which is the else portion. So the else basically means when the num modulus 10 is greater than 5. So it's the opposite of this. The symbol would be flipped in the else statement. For the else, I want to round up, so I would not um, subtract here, I would add. So what I did in the parentheses is also opposite of the if return statement. I used number modulus 10, but that subtracted from 10. So this might sound confusing. So let's use an example again. The one key thing, if you're confused with the program, just test some numbers out, see if it works. So 18 does not work for the if, because 8 is not less than 5. So that means we'll go to the else portion. So we do 18 plus 10 minus 8, because 18 modulus 10 is 8. So it would be 18 plus 10 minus 8. And that equals 20, which means it worked out. It rounded from up from 18 to 20. So now that we know this works out, we just need to add all three of our rounded numbers. So I just said round 10a plus round 10b plus round 10c. I did this because we used the round 10 helper before, so we just needed to call it 3 times for every number that we use, a, b, and c. That's what we have here. And once we finish this, and we know it works out, let's test it by clicking the go. Line C here is an indentation problem. What is line 6? 1, 2, 3, 4, 5, 6. And you see here I'm missing a space right here. And now it should work. Yep. And that's it. Now let's move on to the next problem, which will be Matthew again.
Alrighty, let's move back right here. Alright, so the next question is going to be close far. So close far, oops, let's delete that. So I will give you a couple minutes again to look over the instructions, the test cases, and try and think of a little solution by yourself, and then we can go over it together. Alright, so hopefully we had a good amount of time to think about it. So we're given three integers, a, b, and c, and we return true if b or c is close, differing from by at most 1, while the other is far, differing from both values by 2 or more. So no absolute value of num computes the absolute value of the number. So that's going to be very good for us because we don't want to do -2, 2, 2 when we can just do abs 2, right? So we're going to go ahead and we're going to define our method close far, and we have the parameters a, b, and c. So when we think about this question, it's we have kind of a very direct path. So we got to think, all right, so if the absolute value of a minus b is less than 1, or equal to 1, less than or equal to 1, right? Then we can go on to the next kind of statement. So we think about, alright, so if we know that this is true, so that means that C has to be far from both A and B. So that means if abs A minus C is greater than 2 and abs B minus C is greater than 2, then we can return true. And so in the other case, that one of them is close, then we can return false. So we go back to the original if statement, and we can see we have another case. So we can write another if. It doesn't necessarily have to be an else, again, because else is repetitive. And again, over here, we can just go ahead and remove that entirely and just indent it like that. It's just often slightly easier for us to read it sometimes, and only if it's really like a complicated logic program and there's no real need to save up on space, it can be perfectly fine to just go ahead and write the else. But other than that, I don't recommend a situation in which you would want to use the else statement. So we go ahead and test another case. We do say a minus c. So if a minus c is less than or equal to 1, right, then if abs a minus b has to be greater than 2 and abs b minus c also has to be greater than 2, then we can return true. And again, we don't have to write that else statement, and we can just go ahead and return false. So we can see if we run this. Oops, did I miss a case? Oh, these must be greater than or equal to, because the difference can be 2. Sorry, I missed that. Now, if we just put greater than, it would be for 1. So when you remember, greater than or equal to 2. So we have this now, and so we can see, alright, well, we got all the cases correct. So this is kind of like the basic logic flow, and go ahead and kind of review over this question real quick, because it is a little packed for one of these simpler problems. So it's important you really understand this because you use the same logic moving forward in a lot of the other problems. Alright, so hopefully you guys were able to kind of go through this entire program. So we need to think, alright, well, we went over the cases A minus B and A minus C. But what happens with B minus C? Well, we have to think about it like this. Essentially, when we go ahead and we kind of cover all of these cases here, we want to make sure, we want to think, alright, well, how would each case kind of go down? So we need to think about it. Alright, so if, say, B and C, which are the two cases that seem to be conflicting for us, are close together, right? This kind of logic loop covers that in a way that you might not necessarily think about at first. So again, if you just run through the program yourself using that kind of one gap, if A is far and B and C are close, then you can kind of see if it kind of just covers over that part of the program. So, if anyone has any questions, you can just go ahead and ask them right now. And if not, then thank you for watching. And we can show you. Well, we're gonna be going over the next section next time. So, do you guys have a problem seeing the questions? Because if you do, I think there might be something that we can do about it for next class. Thank you for bringing that up, Aaron. I'll make sure I go ahead and review how I can make that better for next class. So does anyone have anything else? Alright, it looks like no one has anything. So, thank you for watching, and we will see you guys next week.